I realize I've been watching people like sneeze and cough all over Lucy's desk for like the last few weeks and forgetting to clean it in between. My bad. All right. Good. All right. So yesterday we ended with this idea called the binomial theorem. And binomial, we know what it means. And theorem, I think I reminded you of what it meant yesterday. This is a geometry idea. It means a statement in math that has been proven to be true. That's it. So we don't do proofs in here, not really anyway. So sorry about that. But yesterday we were starting to expand this, and I erased the stuff with the exponents. Are we all comfortable with no matter what it is, if it's to the power of 0, it's 1? Like always. Now there's only one exception to that. 0 itself is the exception. 0 to the 0 is not undefined. Your calculator will tell you that it is, but it's not. It's something that we call indeterminate, and it just changes. It depends on the problem, which is a weird idea in math. Okay, you're going to help me with a few more, and we're going to really focus in on stuff. We're going to do like 3 of these, and then we're going to see if we can't find something awesome. So let's try on this one. We'll do x plus y to the 1. What is anything to the first power? What does that do to it? The same thing. Now I'm going to write it much more obnoxious, but do you agree that this, if I wanted to do it like really obnoxious, it's 1x plus 1y. And we don't normally write the x and the y, but do you guys agree that this is true? Okay, for this one, the exercise here is not specifically made for just like foiling and stuff. Anybody in here do squares in your head? Like x plus y times x plus y? So it's not x squared plus y squared. That is the most common mistake, so much so that I call that freshman's dream, because when freshmen learn to do this, that's how they want it to work. But I know it starts with x squared. Now, I'll do some scratch work, and I'll tell you, you do not have to do the scratch work. Anything over here for now, I'll do it. I was going to say pink, but that's the wrong color. If I did x plus y times x plus y, nobody in here seemed really confident that you could FOIL in your head. But check it out. Watch this. You guys are going to help me FOIL this, and we're not going to write anything down. If I FOIL, I would normally draw the lines, right? But I think I can just do this, and we can still see what I'm pointing at. And it's just like the lines. What's x times x? Okay, I'm going to take that x squared, I'm going to put it in my pocket. We'll write it in a minute. We have x squared. What does this give me? xy, and this one? Could I still call it xy? So what's xy plus xy? Try that again. 2xy. xy plus xy is just 2xy. So we had x squared plus 2xy. And then the last term? Did you guys write it down? But check this. I also didn't. What did you say it was? It was 1x squared plus 2xy. And then what was the last number? And I agree it's y squared, but we all agree it's 1y squared. Okay, we're going to do one more here. And here's where we are going to see maybe something awesome shake out. Okay, if I said it is your job to do x plus y cubed, could you do it? Probably not in your head. Okay, if I said just do this, would you guys do this problem and just add this to it and now do the whole thing? But let's think about what we did yesterday. If I know that 2 to the, I'm just going to make up a number, and this is true. If 2 to the 5th is 32, if I wanted you to be able to tell me 2 to the 6th, you're not going to do this again, are you? You're just going to multiply this by 2. We're all cool with that. If I know that this is x plus y squared, and I like, even if I need to FOIL it, and again, foiling is not the focus here, but could I just take this and multiply it by something one more time? I just take this and I multiply it by what one more time? Yeah, it's just another x plus y, just like the other one did. So with just a little bit of scratch work, you guys do not have to write the scratch work, okay? But you're going to help me with this. I'm going to put my x plus y just so we can see it, and this is me doing the scratch work so that you don't have to. So let's look. If I do this, what does it give me? X cubed. Now I'm going to get rid of these so I don't have to erase them later, and I'm pretending like there's parentheses there, okay? Now actually, I can add them now that I can erase them nicely. Okay, this first one gives me 1x cubed. So I'm going to go ahead and do that. 1x cubed. And now, like, we're just going to FOIL it out, and we're just going to see what shakes out. What does this one give me?
2x squared y.
2x squared y. Now, I'm going to do this in a different order than you normally would because I'm trying to do it without a ton of work. Is there another way anywhere in here that I'm going to get another x squared y? Well, you say that, but let's look a little closer. This is 2x times x, and it gives me 2x squared y. What happens when I do these ones? Can we all agree then, and I'm trying to skip work, that we get 2x squared y and then one more x squared y? Do we 3x squared y? Now, again, the focus here is not the foiling. The focus is on these numbers that I'm making so obnoxious here.
I know, I just realized it. I have a question.
I have an answer.
When you foil it, does it matter if you go forward or backwards?
Are you saying if I do this or if I write it on the other side? Yeah. Nope, not at all. Okay, so, and it's nitpicky here, but I wouldn't call this foiling because there's no first, outside, inside, last. We have too much stuff. There's probably a word that might sound like a word and might not, but we're distributing. It's the same thing. Okay, now let's look at our next one. The next one would be, we already did the x squared y's, right? Okay, so let's look at these. This is a 2x squared y. We've already dealt with it. And let's see, this is a 2x y squared. Is there another xy squared that shows up in here? So these two give me 2xy squared, but so does this. So careful, too many. 2xy squared plus 1xy squared. I get another 3, right? Now, again, the foiling, and I can't do these in my head. Maybe I can. I'm trying to do it in a weird order, and I imagine you guys see it as a weird order as well. But I'm going to put these things here, and I'm doing it super obnoxious. That's xy squared. And the very last thing, because I've done every little part except this. 1 y cubed. Okay, do you guys agree with these? All right, now we only briefly mentioned it a couple weeks ago, and last week I think, and Declan, you must have been gone. It must have been at one of the days that the video kind of crapped out on me. Sorry about that. But I want you guys to help me, and if you don't remember, don't just shout it out. If you do remember, I'll come check with you and I'll make sure you can convince me. I'm going to draw something, and I want you guys to draw the same thing over here for me. Okay, I'm going to start with a 1. And I'm not going to draw the big obnoxious ones. I'm just going to draw 1. Then I'm going to do another row of 1s. So now I have a triangle made of 1s currently. Okay, I'm now going to start building this thing out, and we're going to see a connection, and an awesome connection at that. I'm going to wait until you guys catch up. Do you guys all remember doing this? Yeah. Do you remember the rule? Yeah. Okay, so don't shout it out, okay? I'm going to put a 1 here, a 2 here, and a 1 here. Jade remembered it. Who else remembered the rule? Okay, don't shout them out. Do you really, David? Why did I say David? It's either David or David. So I know your name is David, and people say David elsewhere in the world. Like, that's just me being silly. Do you remember the rule? Can you tell me the next row? Don't tell me the rule, just tell me the row. What is going on here? What is this rule? I'm going to do one more row if it's not clear yet, and I'm going to give us like 30 seconds. If you know the rule straight up, I don't want you to spoil it for others. One more.
1, 4, 4, 4, 1.
That's a good thought because you think it's just repeating. People try that. It's not. 6. All right, we're going to build this. Timeout. We'll see. What do you think the next one is?
5. So what do you want?
1.
5. 10. 10. 5. 1.
You're right. Why? What's happening? Okay. So yeah, we're literally just adding these two and then going straight down. And anywhere that we look, it does this. Now, right now, it must have some sort of connection, right? Or maybe not, because I like to do a bunch of random stuff anyway. Is there a connection between what we just did and anything there? Okay, I think so too. I'm going to give you guys like 60 seconds. I want you to talk amongst yourselves and with each other and like audibly. I want to be able to hear it. I'm not going to try to eavesdrop. What's the connection? And then we're going to do something wonky with this. Not wonky, but awesome. So I'm going to pause this. You guys said yes, maybe at least. What is the connection is my only question. I'll give you about 60 seconds with the stuff in purple and this triangle. There is a connection. One, and I'm just doing this so that if Lucy's watching this, 1, 1, 1, 1. 1, 2, 1. 1, 2, 1. Like these numbers show up. Now, just really quickly, and pure honesty, do you love foiling stuff? So you say it's all right, but I'm going to present a challenge. If I said, hey, you and I are going to race, and now we get to do this, are you psyched about having to do x plus y to the fourth? It might be really easy with this. What if I said it's actually 3x plus y to the seventh? Anybody really want to do 7 multiplications and distributions and stuff? Like, I think you could. It would take a while, but you could. Now, what we see here is so valuable, and it's more valuable than we're even going to be able to recognize here. What we see, this picture, is what's known as, it's part of the binomial theorem. It's how we remember it. This is known as Pascal's triangle. Okay, you should have this. This is Pascal's triangle. Super crazy, not really crazy, just an observation of mine. You've probably seen the word Pascal somewhere, and I know you have. I don't know if you remember where. Where does the name Pascal show up?
Pascal Siakam, basketball.
Okay, not what I was thinking of. Clearly, I'm a baller. It's not that. It's something about science.
Yeah.
Something about science. You would have talked about it last year with Miss Forfeit, I guarantee it. Everybody else, you probably didn't talk about it. Are you a sophomore?
Yeah.
So you would have talked about it last year. You talked about it in physical science. Right now, what's pushing on me and you? Gravity's not pushing on me. That's the wrong way to say it. Gravity pulls. And that, like, I know it's like potato, but no, they're way different. But something's pushing on me. Right now, every square inch of my body is feeling roughly 14 pounds of air. What? Right now, like, if anybody notice that there's 14 pounds pushing on you everywhere right now? Yeah. Every single one of us. If you hold out your hand, there's 14 pounds pushing right here on this square inch on my skin, and here, and here. It's not gravity. It's pressure. It's pressure. Real quickly, if we just take a quick side trip to, I don't know, Google, what is the pressure in Unalaska? It'll know what I'm saying. All right, so we're not going to do that way.
In pounds.
Yeah, I don't want it in pounds. Like, so this is a different thing. Here we go. This is like, I have a weather station at home, like not a fancy one, but when you see a barometer, that's the thing that takes pressure. There's a couple ways you do it. If you're in the US and maybe US territory type places, we measure temperature in inches of mercury, which is inches of mercury is how we measure it. Europeans will measure it, if we're doing it that way, it'll be in millimeters of mercury. And what they're talking about is the element mercury, the liquid metal. And it turns out that metals and everything, if it gets hot, it expands. And if it gets cold, it condenses, right? Metals do that. Okay, if we have a metal in a tube and it's really hot or different amounts of pressure are pushing on it, that metal will go up a tube or down a tube less amount. Like, it's literally inches of mercury is how we measure it. But you might use millimeters, or you use this, and this is what I use. This is pretty standard for here. In the middle of the record hurricane, or the record low pressure on our planet like 2 weeks ago, roughly, somewhere in the Atlantic, pressure dropped down to like 800. What do you think this is hecta, like it's just a prefix. It's a Pascal. Pascal did stuff with pressure. Pascal's principle is something that we talked about in physical science a couple of years ago, that you talked about last year. Water pressure, air pressure is Pascal. Now, my not really fun fact, but my fact that I consider kind of fun. You ever met somebody named Blaze?
Yes.
That is so old name. Like, when you hear somebody naming the word, like if somebody names a kid Blaze, do you think, gosh, that's an old person's name? No, but Pascal from the 18th century, I'm sorry, Blaise Pascal. It is a really old name, but it just happens to come back in probably for unrelated reasons, my guess. But yeah, Blaise Pascal. Here's his triangle. Okay, he did a bunch of stuff in physics. We have a connection here. I'm going to show you, and then we're going to refine this. Anybody feel confident that just what we're doing here, could you tell me what the next one is? 1 x to the 4th plus 4
X to the third, Y to the second.
1 plus
6 X Y 2.
So careful. Or notice, if I look at these, what do the powers of x do? They decrease. So we go 4, 3, 2, and now it's y starts at 0, which we don't write it. 1, 2, 3. So this should be 2. And let's see, we go to 4, x, and we finish with a 1 again. Interesting choice, but I agree. Okay. We're not all, I mean, we are all brilliant for sure, but we're not all mentally distributing these, are we? How did we do that? Well, gosh, it's the Pascal's triangle, and it really is a binomial theorem at work. There is a very clear connection. Now, we're going to make a couple observations, and we're going to write Pascal, the binomial theorem. And it's going to be ugly for 1 second. Maybe. I'm going to try to go a little bit faster. We might just avoid the ugliness. Okay. For these, just a couple notes. The coefficients are the obnoxious bold letters that I've done. The coefficients, they match with what? All these numbers that I've written, how do we get them? Yeah, the coefficients match, and I'm just going to say the triangle, because I'm assuming that you guys have this triangle in your notes. The coefficients match the triangle. Now, a couple other things that are just worth seeing. My powers of x, what do they do? And this one's easy to see. The powers of x start at whatever this was, and then they descend or reduce or count down by 1 each time. So they descend. Everybody cool with that? So we're going to say in these expansions and just some observations, the powers, and I'm not even going to call it x this time. I'm going to say powers of, I think I can say the first term, which in this binomial right here, any of them, because they're all the same binomial, what's the first term?
1.
So 1x. So the first term is x. The powers of the first term descend. At the same time, and it's hard to see for that first one, but what do the powers of the second term in each of these binomials do? So notice y is my second term. And I didn't write it. I'm going to write it here, but I'm going to undo it. If I wanted to write a y to the 0, can I? Like, can I add a y to the 0 here and it's the same thing? Not quite sure, and that's okay, but check this because I think you will be sure. What's anything to the 0?
1.
So when I write a y to the 0, I'm really just multiplying it by 1. Now, it just doesn't change it, right? But the reason I'm doing this is because if this is x to the 1, y to the 0, this becomes x to the 0, y to the 1. So I see this happening all over the place. This is a y to the 1. This is a x to the 0, y to the 2. I'm just going to jump all the way down here. This one's going to make it easier. Y to the 0, y to the 1, y to the 2, y to the 3, y to the... What are the powers of the second term doing? Increasing or ascend. Good. I don't know why, but I stress the as part of that. That's ascend is how I say it in my head, and I don't know why. They're ascending. Okay. Do we all agree that those things are true? Okay. Turns out that this gets stuff real nice and easy. I'm going to give you the ugly definition. We're going to do a short brain break, and we're going to do some awesome problems that you probably don't think are awesome, but I assure you the alternative is not awesome for sure. Okay. Here is our theorem. The binomial theorem. And I know we've already written it. I'm going to switch colors because it's important. We're almost to a brain break. The binomial theorem states, and we're going to write it like this way because we can't just say if, like I suppose we could. But the binomial theorem states that for any values a and b, I'll put quotations, a and b, we get the following. If you give me them in a binomial, and it doesn't matter if it's plus or minus in the situation, I'm just going to use plus here. If I take any binomial and I raise it to the power of n, there is a really easy way to calculate and expand this thing out. Now, I do want to just immediately say a really easy way to do it compared with the alternative. Like, this is not the easiest thing that we've ever done, but it's so much nicer than what we have to do if not using this theorem. Okay, we're going to put some ugly stuff here for a second, okay? My first number, we know what it always comes up to be. In every single example, what was that number? When I expanded any of those binomials. It always starts with a 1, right? I'm not going to write a 1 here, though. This is going to look ugly. I'm going to write, and I'm going to do it big here first, and I'm going to write a regular word. So here's a regular lowercase word, okay? Just so you have a scale. We're going to write a subscript, like a submarine underneath, a little n, and then a c, and then a 0. That's what's going here, and then like it's a capital C. So here we go. Ugly notation for a minute. This is n c0, and it's going to be a to the power of n and b to the power of 0. And it's ugly for now. You have no idea what this is. We'll define it here in a second. All I know right now is that nc0, when I write it like this, it's a number. And you guys know that no matter what, that number is what based on this? It's always a 1. So somehow that's a 1. We'll learn the kind of how in here. But notice my first term, was it to the power of n? And then it's going to start, the next term is going to be to the power of 1 less than this. So it'll be n minus 1 on the next one. My power of the second term starts at 0, and the next one will be, it doesn't count down though, does it? What do the other terms do? They go up, so it will be 1 the next time. Yes. Now, here's where it's going to be ugly for just a second, and then we'll come back to this after a brain break. My next number in front, it's not always a 1, is it? Sometimes it's a 1, like in this one, or it's a 2 or a 3 or a 4. There's not a connection there that I know of that you guys are trying to make. We're going to say that number can be written as n, and then a c, and a 1. And I know it's ugly, but we'll clean this up. A to the power of something. What's 1 less than n? N minus 1. And what's 1 more than 0, since we're going up? So careful, not 1 more than n. 1 more than 0 is just 1. Okay, now I'm going to put some dots in here. And maybe we want to do the second one. We'll do one more, NC2. What's the power of a this time? So notice we started at n and we took one away and we got n minus 1. We need to take another one away. It gives us n minus 2. What is b at if it's counting up? Squared. Now, as we get going, because we're doing this just to some unknown number n, we don't know how long this list is, right? Like that happens. What I do know that I guarantee is that eventually, I'm just going to put ... to show that there's some unknown number of missing stuff. Eventually, we're going to get all the way down, and we're going to end with NCN, with a to the 0, and b will be to the power of, what's the biggest power that b will ever get to? I don't think so. Like this was a 4th expansion, right? And a 4, and this was a 3, and it went to 3. What do you think this one's going to go to if it's an nth? N. Okay. It's ugly. I assure you it's much easier than it looks in general. Because I know that many of you are intending to take pre-calc next year, I want to make sure that we can get this notation. I do it more than your book does. Barely. They use like half notation, which if they're going to teach half of it, they might as well just teach the whole thing. Okay. You guys have never seen this. Do you agree? Okay. Check this out. We're going to take a quick brain break and we'll come back to this. We're going to say what these numbers and stuff are, but I'm going to hopefully blow your guys' minds. Maybe. I don't know. I think it's pretty mind-blowing. As we look at these, this language in here, do you guys agree that this looks awful? Okay, that's fair. Like I don't know that I really think it does. In the general form, it is ugly. Okay. This number, we're going to define this. Kind of. When we write these things, N, C, K, and I know that we started with 0, I'm just going to say N, C, K. This thing right here, this is called, and I'm just going to put it in parentheses, this is read as N, choose, K. And what this is it's exactly what we just did in that little thing. If you give me N objects, how many different ways can I pick up K of them? So N choose K are these coefficients, are the binomial coefficients. So that sounds ugly. Binomial because we're expanding something that had two terms, and coefficients because these give us the numbers in front. Now, we're going to make another comment, and I'm going to bring the triangle back down, or if you don't have the triangle, I would at least go another row or two because we're going to put some stuff on it. The weird part about this is when we look at this number, n, and we'll say where n choose k are the binomial coefficients, n is the row.